Good morning, dear students. I hope that you all are fine. Let us continue with the revision, which is a part of our upcoming online examination. The lesson 1 we have already discussed and revised. Today we'll see lesson 2. Is matter around us pure? Classification of matter on the basis of the physical state gives us three main types. These are solids, liquids, and gases. In the last class, we discussed the properties of each. On the basis of though chemical composition, matter is classified into two main types. They are pure substances and impure substances or mixtures. Pure substances are of two types. These are elements and compounds. Mixtures are also of two types. These are homogeneous mixture and heterogeneous mixture. Pure substance is a substance which consists of a single type of substance, which can be element or compound, like for example, iron, copper, hydrogen, oxygen, water, sugar, common salt, etc. Mixture, on the other hand, is a substance which consists of two or more pure substances added in any ratio. Like for example, seawater, minerals, soil, air, sand and salt, sugar in water, salt in water, etc. Differences between pure substances and mixture. Pure substances consist of a single type of substance. Mixtures consist of two or more substances which are pure. Pure substance cannot be separated into other substances by physical methods. Mixture can be separated into its components by physical methods. Pure substance has its own definite properties. Mixture shows the properties of its components. Characteristics of pure substances include its fixed composition. These cannot be separated into simpler substances by physical methods or by physical changes, can only be changed in identity and properties by chemical methods, and properties do not vary. Elements, if we consider, are the pure substance that cannot be split up into two or more simpler substances. These are represented using chemical symbols. Elements can exist as either atoms or molecules. Atoms are the smallest particles of an element that have the chemical properties of that element. Molecules are a group of two or more atoms that are chemically combined. Elements further are classified as metals, nonmetals, and metalloids. The elements which do have shiny appearance, solid at room temperature, malleable, ductile, sonorous, high melting and boiling points, good conductor of heat, and good conductor of electricity in all states of matter are metals. Like for example, gold, silver, platinum, iron, copper, etc. The elements which have dull appearance can either be in the gaseous, volatile liquids, or solids at low melting point at room temperature, brittle if solid, low melting and boiling points, poor conductors of heat and poor conductors of electricity with a few exceptions are nonmetals. Like for example, carbon, hydrogen, oxygen, nitrogen, etc. Elements that have properties of both metals and nonmetals, like for example silicon, are called metalloids. Compounds are pure substances that are made of more than one element bound together during chemical changes or chemical reactions, like for example water and carbon dioxide. Water is formed of hydrogen and oxygen, whereas carbon dioxide is formed of carbon and oxygen. A molecule is formed when two or more atoms, which are different, combine chemically in a compound. Characteristics of compound include it is a pure substance, always homogeneous, represented by formula like, for example, sodium chloride, NaCl, methane, CH4, glucose, C6H12O6. There must be at least two different types of atoms in a compound. These two have a fixed composition and therefore fixed ratio of atoms represented by a fixed formula. Mixtures, on the other hand, are of two types. Homogeneous mixture is a mixture which has uniform composition. The particles of the mixture are not visible by the naked eye. The particles cannot be separated by filtration. The mixture is stable and particles do not settle down. The path of a beam of a light is not visible in the mixture. Like, for example, mixture of sugar in water, salt in water, copper sulfate in water, etc. Heterogeneous mixture is a mixture which is a non-uniform composition. The particles are visible by naked eyes. The particles can be separated by filtration. The mixture is unstable, that is, particles settle down when left undisturbed. The path of a beam of a light is visible in the mixture. Like, for example, mixture of salt and sand, sulfur and iron fillings, oil and water, etc. A true solution is a homogeneous mixture of two or more substances. A solution has a solvent and solute as its component. The component in the large amount is the solvent usually, and the component in the lesser amount is the solute. A few examples are salt solution in water, sugar solution, iodine in alcohol as tincture of iodine, soda water, etc. Properties of true solutions. True solution is homogeneous mixture. The particles cannot be seen by naked eyes. The solute particles cannot be separated by filtration. The solute particles do not settle down, and the solution is stable. The particles do not scatter a beam of light passing through it. In fact, the beam of light is not visible in the solution. When we consider solution, the second type of solution is colloidal. A colloidal solution is a heterogeneous mixture of two or more substances which seems to be homogeneous. Like, for example, mixture of starch in water, egg albumin in water, milk, air containing dust and smoke, etc. Properties. Colloidal solution is a heterogeneous mixture. The particles cannot be seen by the naked eyes. The solute particles cannot be separated by filtration. The solute particles do not settle down. The solution is stable. The particles scatter beam of light passing through it, and the path of light is visible in the solution. Suspension is a heterogeneous mixture of two or more substances. Example, solution of sand in water, chalk powder in water, etc. Properties include a heterogeneous mixture. The particles can be seen by naked eyes. The solute particles can be separated by filtration. The solute particles settle down and the solution is unstable. The particles scatter a beam of light passing through it partially, and the path of light is visible in the solution. When a beam of light is passed through a colloidal solution, the colloidal particles scatter the beam of light, and the path of light becomes visible in cone-shaped structure. This effect is called Tyndall effect. Tyndall effect can be seen when light enters a room through a small hole due to scattering of light by the dust and smoke particles. Tyndall effect can be seen in a dense forest due to scattering of light by water droplets in mist. This picture shows Tyndall effect in different types of colloidal solution. in iodine solution, in solution containing quicklime or milk of magnesia, also in a dark room and in forest. Next, as the mixtures do have different properties, the components are added in any ratio by physical methods, physical changes. We can separate the components by different methods of separation. We'll see next.